Today we are going to be adding health to the entities in the ECS. In order to do that, I will extend the components, and then I will also test the health system by implementing some basic attacking stuff. And when the entity's health reach 0, we will delete the enemies and see if the enemies disappear from the screen. And we have position, we have facing, and I guess I'll add a health here. I'm thinking that health be an S16. U8 is going to give us a maximum value of 255, and it goes down to 0, of course. Let's say we have 4 health left, right? And someone does 7 damage, and we subtract 7 from 4, and we have an unsigned type, then we get an underflow. All of a sudden, the player has a large amount of health. Now, we can obviously do clamping, and we can do testing when we do math on the health, but I figure it'll just be easier to work with signed numbers, and so we can check if an enemy has run out of health by just seeing if the health is less than or equal to 0. I also think we're probably going to have more than 255 health for some entities in the game, so even a U8 is not going to be wide enough. So we'll take the next size up, which is going to be 16 bits, and we'll just have sign 16, and I think that covers both cases of allowing the health to go negative and also giving us a wide enough domain to represent all the health values that we want. So we just added a property here to components, so we'll need to add it to the view as well, and also to where we make the entity view. In addition to that, we will also have to initialize it for the player and the enemies. For starters, I'll give the player 100 health, and I will give enemies just 2 health. I think only if I attempt to move into the enemy should I attack it. Maybe I should add an attack button. I'll add an attack button. Let's make it Z. So if we go back to game, we should have the input struct here, and we'll just call this action. Then we need to make sure we capture that in main. I think it's just called SDLKZ. We don't need to implement enemy attacks first. We can just implement the player attack. I can generalize this update positions to like update state, and then I can test input in update state. And if we do have action input from the player, then the player will attempt an action, not actually attempt movement. We were previously gating entity movement on this flag, but I think this really is just player took a turn. We're also going to set this to true if the player performed an action. So if input.action, we do need to take the cooldown and set that here. This is assuming we perform an action. Wait, we don't need to do neighbors at all because we already have the position of the player and we already know the facing direction. So all we need to do is modulate the position by 1 along the axis of the facing direction. All we need to do is loop through the entities again and search for an entity who shares that position of the tile. We could have a utility function that gets us the tile that we're facing. Get facing tile. It will return a map vector 2f. We need facing direction here. Position and facing direction, right? If we're facing down, then the facing tile is going to be pause.y plus equals 1. Not pause, we went facing tile. There is no enemy on the facing tile. We will take an attack, but we will perform an attack, but we don't have any animations or anything like that. So let's just print something to help us. I don't know how the iterator is set up on the outer scope. I don't know if we can actually like delete an entity from something we're iterating over without invalidating the outer iterator. I guess we can just mess around and find out. I don't want to say for entities. I guess I could say for entities again. We'll just shadow it and iter. Nested entity view here. If nested entity view position is equal to facing tile, then we're just going to decrease the health of that entity by 1. So nested ev.health, and this assumes that it has health, right? We need to, I think, dereference minus equals 1. The health of the nested enemy is less than or equal to 0. We need to delete non-player entity, which the syntax actually looks like that. And then we will just print that we despawned an entity. We will break out of the loop of entities. Then we will say that the player has attacked this turn. And then we will say the EV cooldown prop left S is player run cooldown. We will need to say that player took a turn also for the action here. Okay. I have no idea what's going to happen. I'm going to press Z. I attacked. I press Z again. I attacked. Okay, so the monsters are moving. I'm now going to press Z on this guy. Player attacked entity on tile 38. Okay, I'm going to press one more time. He's got 2 health. I pressed one more time. And let's see, player attacked an enemy on tile 38. So that's working. But then entity Jai 360 assertion failed. Oh, that might have been entity 1. And this also might have been a bug. Equal to protects the player. So I think we were actually protecting the entity, the enemy itself. But we only need to protect the 0 index. Run again. Come find the enemy. Press Z. Boom. He's gone. So despawn an entity, but I cannot move to that position. I can't move left. So it's like an entity is still there. We need to figure out why. Let's get rid of this guy. Boom, boom. Get rid of this guy. Boom, boom. Can't move left. We have this little V shape you can't see. I can't move left, right, or down. And the easiest thing to do probably is just go into GDB here. 1, 2, 1, 2. I will sigint. Let's print entities. The entity count is 1. That's exactly what we want because the view was passed in from the top level game loop into us. So we are propagating the mutation mutation to the entity's view up to the top level game loop. Okay, so proposed position, we get a proposed position, we get the new facing direction, and then we say if can move to entity positions. Okay, I think I know what's going on here. I never iterate over the entities. I iterate over the entire list of positions. I think we just pass in the entities and the components, and then we'll just make an entity view again. Okay, so I'm gonna get this guy 1, 2, he's gone, and I can move 1, oh. That guy only had 1 health. All right, back to debugging. Back to debugging. Hopefully it's a simple thing. Print the components dot health. This is the player. Should be 100. This is one of the entities. It's 2. This is 0, 1, 2. It's 0. That's very interesting. And there's 2. 4 should be has false. Yes. Okay. Oh, I know why. Okay, I'm falling for my own design here. It's because we don't deal with health here, right? We don't do a pseudo delete on health. So every time I add something to the list of components, whenever I don't operate on something via view, but instead operate on the components directly, I need to remember to update all of those sites. Yeah, how can I make sure at call time or even compile time that I have some function that operates on every member of a struct? I could do this with metaprogramming. So we'll compile, we will go back to running, and now I will go 1, 2, 1, 2, and then 1, 2. So that looks good. One of the things we learned indirectly here is we have a 4 entities, so we're iterating over a collection, and then as part of iterating over the collection, we iterate over the same collection again, and every now and then we delete something from that collection, and that deletion appears to be propagated up to the iteration up here. And that's great news. So we don't have to do anything special to handle that. I'm just going to hold down the attack. Well, okay, let's get to a more interesting position where they're far away, and I'll hold down the attack button. Okay, and he disappeared because I was facing him holding the attack button. So if I turn left and hold the attack button down again, boom, boom, they're gone. You guys have a great rest of the day, and I hope to see you in the next one. Peace.